follows our previous video about workload smoothing heuristics. So here actually I offer you another heuristic method to solve the resource constraint project scheduling problem. So this method actually is more well designed or constructed. So the workload smoothing heuristics basically depends on your own judgment when you move backward or forward the activities. So in the constructive heuristics here, you can see I do the same first step. So I calculate the key values based on the critical path method, and then I have a schedule rule. So here I consider the priority rule as the shortest duration. So here, if the activity duration is shorter, then I schedule that earlier. When I schedule the activities at each day, I actually also consider the precedence relationships based on this network here, and also the resource constraints. So now if we quickly go through these calculations, you can see this actually rather efficient method. So we start from activity 2, activity 1 is dummy, and now we see the activity 2, activity 3, and activity 4, they both are the beginning or the start of the project, so they do not have predecessors. So that means we can start these activities at time 0. So I construct a calculation of the form here to show us how to actually choose the activity to schedule. So at the time 0, I have the possibility to start owning activity 2, 3, 4. So that's why this activity called the eligible activity at time 0. And I rank the activities based on the durations. So activity 4 duration is 3, activity 3 duration is 5, activity 2 duration is 6. So I rank these activities 4, 3, 2. And then when you decide which activity to put into schedule, you consider the capacity constraints. So here, resource constraints plays a role. So in the electable, so I probably should have just moved this somewhere else. The electable columns actually decided by the precedence relationships or constraints, precedence constraints. So that looks, hopefully will be easier for you to understand the method. So the electable are selected based on the precedence relationships, and the schedule is based on the resource availability. So in the first, at time 0, so you have the capacity of 10 units of resource. So total for 2, 3, 4, 3 activities, actually they need the capacity of 13, which is higher than what you have. So I only choose to schedule activity 3 and 4 because the durations are shorter than 2. And then activity after you schedule the activity 3, you can see at day 3, at day 3, you come to a new time because now the activity 4 is completed. So you have the capacity to schedule more activity. So you find a new time point, time 3 or day 3. And then you found activity 3 is completed. So from the network diagram, you can see activity Activity 4 is completed. So that means activity 8 now can start. So you add activity 8 into your eligible list. So you rank the duration, activity 8 and 2 based on the duration. Then you have the new activity to schedule. So now you consider the activity 8 consumes the resource of 2 units. So now you can schedule both activity 2 and activity 8, then without violate the resource constraints. So in the day 3, you schedule activity 2 and 8. And then after 1 day, activity 8 is completed. So you come to the new time of day 4. So in the day 4, now you check if you can find new eligible activities. So you see 8 is completed, but you can see 8 actually the successor is a 14, so it's a no successor, no useful successor. So we just do not have new activities add into the schedule. So activity 2 is keep running and until activity at the day 5, actually activity 3 finished. So in the day 5, you can see activity 3 finished. Then you can look into the eligible list. So in the network diagram, you can see activity 3 is completed. So 5, 6, 7 activity now can start. So you add them into eligible list and then rank these 3 activities and then think about your capacity availability or resource availability. Then we schedule both activity 6 and 7 because they consume 1 and 2 units of resources plus activity 2 to 7 units. So the capacity is still okay. Resource capacity is still satisfied. So after 2 days continuously until day 7, so you can see activity 7 actually is completed. Activity 7 completed, so activity 11 is eligible now. So we just go through these steps gradually and then decide which activity to add into the schedule. Now you can see I continue with this process until I put all the activities into my Gantt chart or into a schedule, including both the resource and time schedules. So this look at the total resource, you can see all the capacity constraints are satisfied. So this heuristics is a lot simpler than what we have introduced in the workload smoothing heuristics. But of course, this heuristic is more structured and designed. They also proved if you have multiple jobs, it's better to do the jobs, takes shorter time, then you actually will reduce the average waiting time of all customers or all the jobs. So in this case, it's a reasonable priority rule to consider the shortest duration first. And this is only one example. This is called actually sequential parallel schedule. So you actually can schedule multiple activities at the same time. So you can also do sequential schedule. So each time you only schedule one single activity. So if we do exactly same, but only consider to add one single activity into your schedule, then the heuristic solution will be about 27 days. is actually worse than the parallel schedules. So that's actually another heuristics I would like to introduce. So it just works more efficiently than the workload smoothing method, and also make sure you get a better result than the workload smoothing method.